Hello and welcome. As you guys are getting very close to the end of the semester, I have another video to bring to you to kind of help you with your project journey. And for those of you that are not part of the class that we're currently in, that are just checking out some stuff on machine learning and working with Python and Jupyter Notebooks, welcome. Today, I want to talk to you guys about multiple regression and dummy coding using Pandas, working in Jupyter Notebooks as part of Google Collaboratory, Google Colab. So if you've been following along with the videos I've made so far, I've been working with this 500 row data set that is comprised of 4 columns: gender, height, weight, and index, right? So it's got the gender of the person, their height in centimeters, which will eventually switch over to inches, weight, and index. Okay, so I'm showing it to you in Excel. I like to do that because most people are comfortable with Excel, but as you know, we'll actually take this file, upload it to Google Drive, then mount that Google Drive inside the Google Colab workbook that we'll be working on. So what I'm going to do is I'm going to take this thing, I'm going to grab this thing over, and I've got just a blank Google Colab that we're going to work with. Okay. Blank Google Colab. So first thing I'm going to do is I'm going to connect to my Google Drive. So slowly, and as you guys know, Google Drive is actually pretty slow. She's thinking. There it is. And I've got it in Drive, my Drive, in my regression folder, which we're still fiddling around with. And just like before, there it is, our 500 person gender, height, weight, index, null worksheet that we'll be working on. So this time we're going to do things a little bit different from what we did in the last video. So I'm going to go ahead and we are going to do dummy coding, but I figure we'll just go ahead and do some regression too. So I'll show you how to dummy code and we'll just go ahead and work on a little bit of regression to work along with it. So what I'm going to do is I'm going to go ahead and import the Pandas library. But we're not going to stop there. We're going to use sklearn to, or scikit-learn, to do that linear regression. So we're going to take from scikit-learn linear underscore model. We're going to import the linear regression model like so. Make sure we didn't spell anything wrong. All right, so we're cooking. That's going really well. Okay. So the next thing we want to do is we want to load our data set from that Excel file into Google Colab. So we're going to do that into a data frame, a Pandas data frame. So we're going to go df equals PD for Pandas, right? We're using that alias that I just created, .read underscore Excel. And what we need is the entire full long path. Now the path is, it's going to be content drive, my drive, then the folder that it's in and the name of the file. That's a really long thing for me to type, and I tend to have typos. So I'm going to cheat, and I am going to copy and paste the path in here. Makes life a little bit easier for me. Okay, because it's all but inevitable while I'm trying to make a video in typing and looking at my screen that I'm going to mess something up. So or just make it easy, and we'll do it like so. All right, perfect, perfect, perfect. Now, at this point, you guys know that if I do df, it'll show me my data frame. And if I do df.head, it'll show me the first 5 frames of our data. And what we see that we don't like here is a couple different things, right? We need to do a little pre-processing. Several things that aren't going to work for us here. So the first thing is we don't need this index column, so that can just go away. We see that we've got a categorical column, right? It's got values that are non-numerical. That's not going to work. We'll have to do something with that. And then also we see we just have some straight null values here. So NaN is not a number. It's just missing a value here, which we'll need to fix that as well. So let's kind of get into that a little bit and see what we can do to make things work. So we'll start off with the easy part. Let's drop the index column. So we don't want that. So I'm going to use the drop method. So I'm going to say data frame dot drop, and then I am going to drop the index column. And as you know from before, it's not enough to just do drop column. I need to tell it specifically that we are going to drop the column and we want it to stay. So I'm going to do in place equals true, like so. We want that to stay. So let's do this. All right. So now if I look at my data frame, we're doing well. So the index column is gone. So let's quickly break that down for a second. So I use the drop method, right? So data frame's the object, drop method, and I'm specifically looking at the index column. I had to tell it we're dropping the column, and I'm saying keep this change that we've made. So when I say in place equals true, that means that it's not going to just do it once. It's going to stay as long as I'm working on it in this file. So that's handy dandy. So we've got a couple other problems here that we'll need to fiddle along with. One of the problems that we have to deal with is that there are null values. Now you can just see it with your eyes when I look at the head and the tail of this file, but you know that I can also do df.isNull. And if I do that, it's going to tell me false for every place that there is a value, and that's a good thing. And if you see true, like where we have right here, that means that there's a null value, and that's bad, and we don't want that. Okay, that's a bad thing. So there's a couple different ways that we can attack this, right? But let's look at the big thing again. So if I do df.isNull, so the isNull method, I can then do sum, and what this is going to do is it's going to add all the trues. So anywhere that it finds a true in this data, it's going to tell me 2. So for example, in the weight column, there are 2 null values. Now there's a couple different ways that we can attack those null values. We've got several different methodologies that we could touch. Probably the easiest thing to do would be to just drop them because there's only 2. In a previous video, I showed you ways that you could substitute values in, like you could substitute a mean or a median or a mode. But in this case, because it's only 2 records, really probably the easiest thing to do would be to data frame.drop in A, and we'll do we will do in place equals true. So we'll go in place equals true. There we go. So now if I look at our data frame again, look at that. Now there's no holes. Now let's make sure that we've got that too. And here's what I did. So drop in A is just a different kind of method that we can use. So basically anywhere where there's a null value, we can drop it and we want it to stay. So we want to continue to use this data frame without the null values. So I'm going to say in place equals true. So remember we had 500 records to start. Now if you look down at the bottom, we've got 498. Now remember you start at 0. Okay, so this should say well, what did we drop here? Let's see what we dropped. So we'll do df is null. And we should actually be in good place here. df.is null. Dot sum. Yes, we're in a good place. So things are looking good. All right, so this is going smashingly well so far. So our first issue has been resolved. Okay, so we've got a couple other things we want to fiddle around with here. So one of the other issues we have is that we've got gender here. And this gender column that we're looking at, it's got categories in it, right? It's got nominal data, not necessarily ordinal data. So what we need to do here is we need to one-hot encode this data. Okay. And if you're not familiar with one-hot encoding, basically it's going to replace the words with numerical values that the computer will actually understand. But when it does it, it's not going to just do like 1, 2, 3 or 1 for male and 2 for female. It wouldn't do that because if you did it, it would think that it's ordinal. What would that mean? So a 1 would be a greater rank than a 2, for example. So first place, second place. We really can't do that here because male and female would be equal. So what we want to do is we want to do something called one-hot encoding. So we want to take this and we're going to create 2 columns. There'll be a column that says female and there'll be a column that says male. And if the person is a male, where the male category is, there'll be a 1, and where the female category is, there'd be a 0. And if the person was a female, where the female column would be, there'd be a 1, and in the male column, there'd be a 0. Now it seems confusing, so the easiest way to do it is for me to just show you, and what I'll do is the get dummies method. So I'll make it simple. I'm going to create a variable. We'll call it one-hot encode. And what we'll do is we'll do pd.get underscore dummies. And we want to get that. Did I spell that right? Yes, I did. From the df.gender column. So now when I do that, if I look at the one hot encode, it's going to show me this data frame. Okay. So all I've got right now is I've got a new data frame called one hot encode. So I've still got my other data frame. Right? There's my other data frame, but I've also got the new one that I've just created. Okay. And it's now got 2 columns in it. These are one hot encoded columns, and there is no limit to the number of things you can do this to. You can add multiple columns to that get dummies, and you will just keep expanding out. So you'd have female, male, and other things as well. Okay. So for example, the first record was a male. So there's a 0 in the female column and a 1 indicating that person is a male. This we can understand, and that is a good thing. Okay, so we've got that. The problem now is that we've got 2 different data frames, and that also doesn't help us that much. So what we need to do is we need to smush those 2 data frames together. So the way you do that's actually really, really easy. What we're going to do is we're going to concatenate it. Concatenate is a big word, but it comes up all the time in multiple languages. You can concatenate in Excel. You can concatenate in Visual Basic. You can concatenate in, well, really just about anything. So all it means is basically combine. It's a really fancy way of saying smushing 2 things together. So we're going to take our original data frame and we're going to take our one hot encoded data frame and we're going to smash those things together with all the columns. So we're going to take the 2 of them, we're going to put them together kind of like a join would be a good way to look at it. Kind of like a join, not necessarily in a pen, but like a database join. So what I'm going to do is I'm going to have my final data. And you could call this whatever you want. Basically, it's a variable name. So I could call this anything I want. But what I'm going to do is I'm going to do pandas, and I'm going to call the concat method. So concat for concatenate. Pretty similar to what you can do in Excel, actually. There's a concat in Excel as well, but it's spelled slightly different. And what I want to do is I want to concatenate my original data frame with my one hot encoded data frame. And I want to take all the columns. Sorry that it's giving you this pop-up. We don't really need it, but it's showing in there. Take all the columns. So we're going to do access equals columns, like so. And if we're lucky, we look at final data, and there we have it. So now we've got gender, height, weight, female, and male. But our data still could get a little bit better, right? So now we've got the gender column here, and we've got the one hot encoded columns here, and we don't actually need this original gender column anymore. So now we want to drop that one, right? So let's go ahead and drop that. So from our final data frame, we are going to drop the, what do we want to drop? The gender column. So gender column. And we want to say the axis columns. Okay. And again, we want that to stay. So we're going to say in place equals true. And now when we look at this, we should see we've dropped that next column, right? So we're just moving right along here. Things are going very, very well. So now I've got to give you a little theory for a second, because we're going to drop another column, actually. We're going to drop the male column. So when you get deep into this, and it's just a good practice to keep in mind, and let me pull this website and show you. You have something called the dummy variable trap when you deal with dummy encoding. So here's a website to show you. See it? The dummy variable trap. So when you guys took class back at the beginning of the semester and we were in SPSS working in regression using just traditional statistic techniques, we talked about all these different assumptions when creating a regression. And there are all these different things we want to watch out for, right? We want to watch out for outliers. We want to make sure we have a strong enough sample size. There has to actually be a linear relationship. And with a lot of statistical techniques you'll hear people talk about collinearity. And that's an issue that you can run into when you're dealing with dummy variables, because really they do change simultaneously. So if you look at female and male, In this particular type of data set, you're only going to be one of them. So if you're a male, by default, you're not a female. And if you're a female, by default, you're not going to be a male. Like it's one or the other, which means that if you know the answer to this, you also by default know the answer to this as well. Because you can only be one or the other. You can't be both in this particular data set. Could be different if it was a different kind of data set. But in this one, you only get to be one or the other. Okay? Only get to be one or the other. So in this particular case, we don't need both of these. We really only need one because by default, if you know one, you know the other one, right? So like if this is not a 1, by default, that's a 0, and this is a 1, and there you have it. So really what you want to do here is drop one of these one-hot encoded columns. It could be either one. It doesn't really matter. So I'm just going to go ahead and drop the male column, and I'm going to cheat because I already typed the data here to drop something, right? So all I need to do is copy this. And I'm going to pop down here and I'm going to paste it in if I copied it correctly. And I'm going to change gender to male. And now when I look at this, things are getting way better. Things are looking really good here. Really, really good. So now we've got to think about our X and our Y, right? So our predictors and our outcomes. Right? We got to start thinking about our X and our Y, our predictors and our outcomes. So there's a couple other things that I want to do to kind of make this thing work a little bit better for us. So what I am going to do is I am going to rearrange the order of the columns. Okay, I'm going to rearrange the order of the columns. So right now I've got height and I've got weight and I've got female. But really what I want to do is I want to move these around where I've got female and then I've got height, and those will be my predictors. And then my weight will be my outcome. So if I know your gender and I know how tall you are, I should be able to predict your weight is what I'm saying. So I just want to juggle these around. Just makes life easier when we get to the regression part. So I'm going to use another little trick to move those around. So I'm going to take my final data and I'm going to use lock, which I've heard people say loc. I've heard people say lock. In my mind, I see this as lock. There's lock and there's iLock. You tell me out there, write in the comments if you pronounce it lock or loc. I pronounce it lock. But hey, you know that it's LOC is what we're typing, right? So we're going to use the lock method. So we're going to do final.loc, and it's actually location is what I think it's for. So loc would actually make more sense. But in my mind, I see lock. I don't know why, but yes, now that I think about it out loud, location is what that is. So loc is really what it is. So we're going to do final.loc, even though I want to say lock. And we're going to start with brackets. And here's what we got. So we don't want to mess around with the rows at all. So for the rows, I'm not going to do anything. So I'm just going to plug a colon in here, and I'm going to do a comma. And what I'm going to do next is I'm going to add another bracket here. And I'm going to arrange the columns in the order that I want them to be in. So I'm going to put female first. And then I'm going to put height second. And then I'm going to put weight last. Oh, I need to put the weight last like so. And you got to make sure. So we've got bracket here, and then we've closed it there. Looking pretty good. And now we're really, really going well. So everything's looking pretty good here. We've got this set up exactly the way we want it to be. So at this point, we are ready and set to go ahead and do our regression. So if you don't care about doing a linear regression, this would be where you could stop. We don't need to continue. We've done the dummy variables. We've gone through and we've set up the data set to work exactly the way we want it to. So this would be a good place to stop. I do actually have another linear regression video, but at this point, all you'd need to do would be to create the regression object, fit the object to your data, and that's pretty much it. There's really not more to it. I can go ahead and do it really quickly just to show you. So I can go regression, model, I'll give it the name regression model, equals linear regression, like so. And from there, I actually meant to just do this like so. I can do my regression model.fit method, right? And I want to take my final data. There we go. I want to take my final data. And inside that final data, I want to take female, and I also want to take height as predictors. So those are going to be my X's. Okay. And then I'm going to take my final data dot weight as my Y, like so. And assuming I haven't mistyped anything, which you never know, there we go. We know we're working. So at this point, I could do regression model dot coefficient. And when I do that, it'll tell me my coefficient. So there's my weights. If I do regression model dot intercept, it'll tell me my intercept. And if, what did I spell wrong? See that capital E right there? Capitalization matters. There we go. It'll tell me that. And if I wanted to actually use this, I could say regression model dot predict, and I would pass in the values as an array that I want to work with. So we'll say that it is a female that is 130 pounds. And it's going to give me a prediction. It's going to spit something out like so. Okay, so that's sort of it in a nutshell. Not too much to it. Hopefully this gets you going. It's not the most robust data set, but it gives you the concepts of how to dummy code, how to rearrange your data a little bit with some more pre-processing to get things going. Hopefully this is working out for you. I don't usually make a lot of videos on this particular topic, but I'm actually finding it to be kind of fun. So if you're interested in other things, I might pop a few more out there. If you got some cool tricks that maybe I didn't think of, I'm always open to suggestions. But for now, I will stop this and I will talk to you guys soon. Good luck with class and finals and presentations next